Good morning, colleagues. Today we are going to solve the exercise 3.9 from the book Fundamentals of Electrical Circuits by Sadiku. Here they ask us to determine the current IB that circulates here. In this circuit we have a voltage source, but unlike the previous exercise, this is controlled by current. Well, the first thing I always advise is to review the circuit in such a way that it is easier to understand it. For example, here I am going to change this voltage source with this resistance. Since they are in series, nothing happens and the analysis will be better for me. So, redrawing the circuit, I get that here is a resistance. Here's another resistance. 50 ohms. 250 ohms. And here I am going to put the resistance first. And here I'm going to put the voltage source current controlled. And from here I'm going to put this as 150 ohm. No. And all of this is connected to this point. Let's observe. It tells me that this source depends on the current that circulates here. That is, the current NV. Okay, so I'm going to do it here. It tells me to use nodal analysis, so I have to analyze the tension at this point. Now, this is 24 volts. So, the first thing to do is a visual analysis of the currents through which they circulate, depending on the voltage or current sources you have. I say that here comes a current in this direction, product of the polarity of the voltage source in the dependent voltage source, and here at this point the current and Vs and the current will arrive. This current, which I have not yet named, and from here it flows to one side. I say that it comes this way since it is not connected to ground, right? Now, doing the current ESC, I'm going to put at that point the currents that enter as well as those that leave. So I'm going to give it the name of the current I1. This I'm going to call the current I2. So I say the current IB plus the current I2, which are the two that enter that node, will be equal to the Y no. Then the current that has that direction will be equal to 24 minus the voltage V. Because if it has this direction, the voltage 24, I am assuming that it is greater than V, but that is later given to us by the analysis of the resistance of 250 ohms plus the current I2, which is what I say is 60, and V. Yes, because it is 60 and V minus the V1, or the V, I called it V, over 100. All this is going to be equal to the current that comes through here, the I1, that is going to be V over 50. Okay, now I'm going to come down here. I need to know, I have a variable that is unknown. I have an unknown variable, but this V, which is the one here, which is the same one that is here, tells me that it is the one that comes here. Ah well, the current and V. It is the one that comes here, and the one that comes here is 24 minus V over 250. Here I have it 24 minus the V that I put here over 250. I know that the V, it's equal to 24 minus V over 250 east and V. What I'm going to do is replace it here. Well, I'm going to continue. I'm going to leave the equation here to see it. So I'm going to do algebra and then I'm going to introduce that idea. So I'm going to have to 24 about 250. I'm separating this minus V over 250 plus 60 over 150, which multiplies the YV. But we had said that V is 24 minus V over 250. I'm going to put 24 over 250 minus V over 200. I'm already separating this, and this is the V, right? Well, except here. The V over 150. This is going to be equal to V over 50. Okay, let's go. I'm going down. Now, I'm going to leave aside everything that has the variable. And the same on the other side, everything that is constant. So I'm going to put minus V here. About 250. What is this? First. And now, if I multiply 60 by 24, if I multiply this with this 60 over 60, 50 over 24, over 250, it will give me 24 over. If I'm multiplying this with this and now this with that, it's going to give me minus V over 625. You can corroborate it with the calculator yourselves. Minus V1 minus V2 250. And I'm going to pass this thing that is here to the other side of the same. Therefore, it passes with a negative sign. It would be V over 50 equal to this. This man had passed it to the other side, like so. Then it remains minus 24 over 250. Well, here I have another constant, that I am also going to pass to the other side in the same way. So if I operate this with this, that is, minus V over 250 minus V over 625 minus V over 150 minus V over 50. All that is going to give me minus 121 over 3,750. Please verify yourselves. This is equal to EH minus 24. About 250, and this thing that was constant here, I have to transfer it to the other side as well. Minus 24 over 625. Well, we continue then. Here it would be minus 121 over 3,750 V. Maybe if I operate this it will give me minus 84 out of 625. So V is equal to space. I multiply this with this and pass this. With this the negative is eliminated. I'm going to have 504 over 121 equals 4,165 quarters. Then that voltage will be equal to 4.165 volts. Now I already have the voltage at this point, yes, but they ask me to finish and V we had already said that it was 24 minus V over 250. 24 minus 4 minus V over 250 was NV, so NV make 24 minus V, and we now have the value, which is 4.165 over 250. In the end this will give me 0.07934 amperes or 79.34 milliamps. If you multiply this by me and you give me milliamps, then that's the current NV.